I was saying to you before we started, it's nice to kind of deliver these kind of things in short, snappy bursts, because it's kind of a good overview that you can watch again and again. So it's certainly something we might look at in the future. So today's presentation, as part of the Comfort and Energy in Construction webinar series, is going to focus on airtightness. And our company, Ecological Building Systems, is well positioned, I suppose, to talk about airtightness in general, because to the best of my knowledge, we are the first supplier to bring in an airtight system into the market. So we're going to talk generally about airtightness, not products and things like that, but we are well positioned to see trends and issues and future trends and things like that, and the developments within this area. Airtightness is a key part of building performance. In fact, it's one of the pillars of Passive House, along with things like super insulation and triple glazed windows. You just cannot have an energy efficient building without airtightness, and some would call it the sleeping giant of energy efficiency for many reasons. Some of them we may touch on. My own background, what kind of qualifies me to talk about energy performance in buildings, is that I would have studied topics like energy in construction and engineering and energy management and things like that. So I'm well positioned to understand the influence that things like airtightness have on buildings. But when I started with Ecological Building Systems 6 years ago, I actually started to learn about those things, really. So everything I learned in college was just words until I seen it in practice on a daily basis. And I've been learning more and more since I worked with Ecological Building Systems, particularly around the importance of airtightness generally. Our company is a division of a larger company called McCann & Byrne, and they're a generational company that's still owned by the same people today, the McCann family. And around the year 2000, they noticed a big change when they were working with product partners out in Europe and stuff like that. And they noticed a big change towards high performance building in the mainland Europe, particularly Germany. So at that time, they sent out some requests to suppliers, to see did anyone want to work with a company based in Meath in Ireland. And they did that by fax, because in those days, that's what you did. And one company came back, which is the one you see on the top right of that slide, Proclima. And Proclima are, as I said, an airtight manufacturer. So they supply the products that we've been supplying for them in Ireland and the UK for 2 decades. So with that in mind, and with our experience with airtightness and things, we'll just jump straight into it and have a look at what are the current trends. The big current trend that you'll see in terms of airtightness is that even though it's moving slowly, we're being obliged to build our houses more and more airtight, and our buildings more and more airtight. And this is a good thing. When we buy a car, we don't expect it to be leaky. We just assume this car must be airtight. We don't think about it, but if we drove it down the road and the car had some air moving into it when we were driving the car, you'd bring it back because there'd be something wrong with it. Now, this is kind of what I'd like to start with, because that's how I like to think about airtightness. The building should be so well built that it doesn't have any wind blowing through it, for the same reasons. You just expect it to be that well built. Now, before November 2019, the leakiest house we were allowed to build legally was a house that had an air permeability, or a Q50 value, they call it sometimes, of 7 that you'll see in red there. Now, what that figure stands for is when a door blower is on a building, and it's sucking air out of a building or blowing air into a building, only 7 cubic meters of air are allowed to leave that building envelope for every square meter every hour. So the higher that number is, the leakier the building is, because it's more cubic meters of air. So before November 2019, we were allowed to build a building that had a Q50 of 7. That's a very, very leaky building. In the UK, by the way, up until very recently, and it's changing as well, the Q50 value was 10. And just to put that into a little bit of context, because 10 is a nice round figure, if you had a 200 square meter building and you had a Q50 of 10 in that 200 square meter, I mean the surface area of the envelope, what that would represent is a hole the size of a 20p coin in every square meter of the building fabric. So that's how leaky a 10 would be in that context. But how things have been moving have, since 2019, when NZ came into law, our obligations have tightened slightly. So since 2019, we're now obliged to build a house no leakier than 5. But we still have a long, long, long way to go, because 5 is some way off the passive house standard, which would be seen as the gold standard of construction, in my opinion, and in many others. So when you have an air permeability of 5, you're still allowed to leave permanent vents in walls as a compliant ventilation method. So as long as you get below 5, you're compliant and you can get your BER assessment. And as long as you stay above 3, so you don't go any more airtight than 3, you're allowed to have background vents and permanent vents in walls and things like that. So it's not very adequate for a high performance building to be building it with so much insulation and just poking a couple of holes in the building. It's a little bit counterintuitive. The good news is that in Ireland, evidence from deep assessments show that on average, this is since 2021, the airtight results that we're attaining on average is 2.58. So that's great. On average, we're building buildings so airtight, almost twice as good as the building regulations is asking for, but so airtight that we must now look at controlled ventilation systems. Because if you get a value lower than 3, you require a controlled ventilation method in your building. And today is not about ventilation. I know that Dara will be talking about ventilation in tomorrow's presentation, which should be good, but I'll have to touch on it briefly because airtightness is very linked to thermal performance of insulation and also ventilation and indoor air quality. So I'll be touching in and out of those subjects. Only 17.7% of new homes have natural ventilation since 2021, according to the same source. That shows a huge swing towards controlled ventilation methods. So we're building our houses more airtight and we're planning for ventilation at the same time, which is the way NZEB is trying to push us. Almost a quarter of the naturally ventilated homes, so the people that didn't plan for ventilation, almost a quarter of those homes had airtight results lower than 3. That means that they're non-compliant with Part F of the building regulations. They decided early during the planning phase, with maybe a lack of foresight and planning and understanding, that no, we don't need a ventilation system. We're happy with the hole in the wall, no problem. But they built their house so well that they got a Q50 lower than 3. And then when it came time to do their door blower test and get the result and get a BER assessment, they had a big red X because they don't have provision for fresh air in the building. We are, however, quite a good bit ahead of our UK counterparts, and a man called Barry Cope from the Airtightness Testing and Measurement Association, which is the ATMA acronym there, in a webinar last year, he looked at the permeability results from a really big database, 600,000 homes in the UK. So he took all of their energy assessment information and he evaluated it and he broke it down. And it's clear, really, the first thing I would jump to without looking too much at the table is that the construction type doesn't have much of an influence on air permeability. If you look at that table and you look at the first one there, block and brick, on average in that 600,000 homes in the UK, their air permeability was 4.64, so nearly double what the average is in Ireland. But on their timber frame building, which is typically seen as more airtight form of construction because it relies on membranes and things like that, their average is actually only 4.4. So it's not a big move from block and brick. So the type of construction is not really influencing the average air permeability. It's more a case of build quality in every case. In the UK, 62% of homes are still being constructed with background vents. So that's largely because their building regulations still say they're allowed to build quite leaky buildings. So that's a direct correlation to that. But since 2015, the data shows that 10% less homes are selecting natural ventilation as a strategy. So the trend over the last 5 years shows that their averages are improving by about 0.15 annually. Which is about 3% better every year. So they're coming along nice and slow, and it is getting better. And that's the trend in both Ireland and the UK and Northern Ireland, is things are moving in a better direction. So what are the common issues with air tightness? You can look at this millions of different ways, and so we don't know everything, but from my point of view, one thing that I've noticed since I went to college and I learned about airtightness, and then I started working for ecological building systems and I learned about airtightness, is the actual word airtight can be a little bit difficult to wrap your head around. because no one wants to think of themselves living in the coffin, the airtight coffin where there's not enough air. You can't open your doors and windows and you have poor indoor air quality and you might suffocate. But those are all the wrong ways to look at airtightness. And in fact, airtightness is not the bad guy. But it often gets that on site. So you might get a builder saying to you, geez, who'd want to be in an airtight house? But they're kind of missing the point, because of course you can open your doors and the windows. That's occupant behavior. The airtight value for a home, or the draft-proof quality of a home, is the same as you'd expect for a brand new car that you're buying. It should be so well built that it's just not leaky. So of course, it's a mental challenge really for a lot of people to overcome the perception that an airtight building is a better built building, and not one that affects the quality or the amount of air they have to breathe. But the market's becoming more aware and educated on this topic, and that there's a correlation directly between good IAQ, or indoor air quality, and airtightness. So it becomes more clear, and airtightness is not the bad guy, as I said. It's just that a lack of proper planning is what actually leads to poor indoor air quality. If you build your house so well that it's not very leaky, you should have an adequate ventilation system to go with it. So a controlled ventilation system is an important step in any building. Retrofit a new building, it doesn't matter. In this situation here, what you see is a building that has a wall vent on the wall, a permanent opening. And this building is suffering from very poor indoor air quality and mold growth on surfaces. In this situation, it's a combination of two things. It's a combination of cold surfaces combined with high humidity in the space. And the high humidity in the space is not being controlled by a permanent vent in the wall. And why is that? Because sometimes those vents are reliant on wind pressure. If the wind's not blowing, you may not have a pressure differential to blow in air and take out air out of your building. So very often it's completely uncontrolled or unplanned air movement. And as it says down the bottom, unplanned air movement can cause poor thermal comfort, surfaces become cooler, and the risk of condensation and mold is increased. So the more we make our buildings airtight, the more focus and attention we have to put on the ventilation system also. What are another common issues? Well, something that all suppliers are feeling at the moment is price inflation and the supply chain. I just took this snap from the journal.ie online, and it's something we're all used to seeing nowadays, but the rising cost of building materials is getting worse on a weekly basis. And everybody who's building or doing small projects or purchasing material would be aware of this, that it keeps going up and up and up in a very unpredictable way. So global factors are influencing the market price largely, and built up demand since COVID closures, although that's kind of eased off a bit, but the demand is still largely there, and the market is still competing for containers and for transporting goods and raw materials. So all of these things are affecting the price of materials and the price of transport, etc. So it's a little bit volatile at the moment. It's not just in terms of airtight products, it's also in terms of insulation, steel, timber, blocks, any building material really. The supply is struggling to meet the demand, of course, because we have such ambitious retrofit targets of achieving 500,000 retrofits by the year 2030. Approximately 50,000 needs to be done annually. And we also have a housing crisis at the moment where we've got a huge shortage of houses. There's a lot of construction activities still underway, and we really just don't have the workforce to deal with a lot of this. So at the moment, it's estimated that there's a 27,000 person labour shortage in the industry, and a further 17,000 required for the retrofit sector, which is why you see currently, great work being done by the people in Mozart, delivering training for centres like LOETB to train people in the quality installation of products like insulation and airtightness and things like that. And they're actually currently developing a national airtightness and vapor control installer course at level 5, which is brilliant, because this is going back to one of the trends. The trends are that we're moving in the right direction. And if we keep lowering our airtight value, we need people that understand what they're doing and how to install it well to get those lower and lower values. Ultimately, passive house being the end goal, in my opinion. But if people aren't trained properly to give an awareness and a basic understanding around the products and systems and things like that, they're going to struggle. So yeah, this is a current trend that's going on at the moment, but also a future issue trying to meet the demand that's out there. The future trends that we're seeing are a lot of modular building and modern methods of construction. And these types of approaches to construction and design are helping to de-skill airtightness, because airtightness can be seen as a complex topic when it comes to the designing of airtightness. When you take it off site into modular panels like these, completed by Fallis Construction Limited, you really improve the time it takes and the material efficiency, so the usage and the quality of install and things like that. So in this case, Fallis Construction were building thermally broken timber panels, and they were injecting those panels with I think blown cellulose in this case, which is a blown newspaper. And on the outside of the panel, there's a blue breather membrane, a peel and stick membrane called Saltex at Hero. And on the inside of the panel is a certified vapor tight and airtight racking board called Finsa. So they're doing all that off site and they're just shipping it into place and taping it up and things like that. So it's really de-skilling the whole process. And we're seeing this more and more. Another future trend is manufacturers are having to innovate largely because of the way the market's gone. You're seeing much more retrofit underway, particularly in Ireland. A lot of retrofit is taking place, and the targets are equally as stringent for retrofit when you trigger your NZEB obligations. So it's critical to get your airtight detailing correct, but sometimes taping during retrofit can be too difficult. It can be hard to tape between exposed floor joists and into difficult area where there's big bunches of services and things like that. So you're seeing things like the airtight paints coming onto the market, and the methods of application being quite varied. So being able to put them through airless sprayers, or on with paint brushes, or on with application tools like the Aerofix you see in the middle of the screen. And really what that's helped to do is de-skill the application process of tapes. So it's meant to be getting easier and easier all the time, and it is. And this is largely due to the innovation of manufacturers like Proclima. Also, there's a direct correlation between the cost of airtightness on site and early planning. So if you fail to plan, what can happen is you can miss a key junction. Then you can end up doing a lot of taping. And as a result, your costs can be much, much higher. But if you plan it early and you see the junctions, you might have an opportunity to simplify things. So, as I said, improved understanding of good material selection and when planned airtight details is certainly something that's getting better all the time. So designers are getting more and more adept at designing for airtightness, and installers are getting more and more trained thanks to the work of people like LOETB, Mozart, Ecological Building Systems, and others to try and train the market and educate the market. So thank you. I don't think I went too far over my time today. We do have a lot of services that we can offer, and I know this is being recorded, so I just threw up a slide with our contact details in case anyone would like to get in touch. So thanks for listening.
Perfect. Thank you, Joe. That was brilliant. I like your the whole idea of planning first. It kind of reminds me of the age-old saying is like measure twice, cut once. So
that's right. Yeah, I come from a trade background. I've heard that a few times. Unfortunately, I've often cut twice.
And just looking through, does anyone have any questions? You can type into the chat if that's okay, or if not, we can leave it there.
And feel free to contact me directly either if you like. You can send me through any questions you might have if you're doing projects or anything. We're happy to help.
Perfect.
That's great. Thanks, Stevie.
Okay, that's perfect. So thanks everyone, and please join us tomorrow for Dara will be talking from Partel about ventilation. And yeah, thank you for all coming, and good luck.
Cheers. Bye-bye.